You're listening to Innovators, the podcast from Harris Search Associates, where we speak with global leaders in education, research, engineering, and the health sciences, and ask them to share lessons learned as they continue to advance the frontiers of innovation and discovery. Today's podcast will be led by Rick Skinner, Senior Consultant.
In the midst of a global pandemic, assessments of the state of research in other fields of medicine can often be set aside. After all, the nearly 1 million deaths due to COVID-19 and variants in the United States to date exceed the two other leading causes, heart disease and cancer. But research in fields other than virology and immunology, for example, do not stop, though they may slow as attention and support are diverted to address the COVID crisis. Moreover, the research on COVID has produced findings that appear to have direct and indirect implications for inquiry in other fields of medicine. The time, therefore, seems right to hear from an authority in one of those fields, in this case, cancer, as to what the state of affairs is at this time. And we are very fortunate to have with us today on Innovators a leading scholar researcher to provide us his assessment of where cancer research is at present. Raymond Bergan is Professor of Medicine and Deputy Director of the Buffett Cancer Center at the University of Nebraska Medical Center. Recognized internationally as an accomplished physician-scientist and as a cancer researcher for his work on the spread of cancer cells and the development of preventive treatment for high-risk patients. Dr. Bergan's career began at Northwestern University, where he served as Director of Experimental Therapeutics and leader of the prevention program for the university's Lurie Comprehensive Cancer Center. In addition to breakthrough work on early phase cancer chemo-prevention, he demonstrated a new technique for measuring prevention therapy in the individual cancer patient, an important step toward precision medicine and personalized therapy. In 2015, Dr. Bergan was recruited to join the Oregon Health and Science University as head of Hematology and Oncology and as Associate Director of Medical Oncology for the Knight Cancer Institute at OHSU. There, too, he led work that enabled individualized patient treatment with greater precision of effectiveness in ways that can change how cancer is treated henceforth. In late 2020, Dr. Bergan joined the University of Nebraska Medical Center. His undergraduate degree is from the State University of New York at Buffalo, and he earned the MD from the SUNY Health Science Center at Syracuse, where he also completed his internship and his residency. He was awarded 2 fellowships in the National Cancer Institute of the National Institutes of Health. But amidst all his accolades and accomplishment, Ray Bergan's real distinction may well be an observation by his spouse, who noted that whereas most of us go through our day caught up in the details of the moment, he navigates his daily toil, preoccupied by scientific and clinical riddles he is convinced can be solved. Welcome to Innovators. A half-century has passed since the federal government declared war on cancer and made a commitment to begin building the research capability to understand better the biology of the disease through research. The National Cancer Institute and other cancer-related organizations made 2021 and the 50th anniversary of the original declaration, a year during which the research effort would not only not flag, but it, quote, nothing will stop us. It seems to me implicit in that communication is that the war, notwithstanding some real successes, has not yet won the victory over cancer. Where is research at this point? What do we know with certainty about the disease? What appear to be promising avenues of cancer research? And for that matter, might this be a good time to revisit the original war declaration that we proclaimed and assess whether that goal of a war that defeats cancer might not be appropriate now, given the fact that we know so much more about the disease? So where are we?
No, those are a great set of questions, and I'll start from the last one, talk about it, and please remind me to drill down more. But, I think it is appropriate that we reassess, the war on cancer and our declaration. Our successes notwithstanding, but we cannot talk about it without talking about our successes, because there's a balance here. And so let's turn the clock back. And so we're in the early 70s, and there was something called the C word. Nobody talked about it. And if you had it, you were basically socially isolated by society, or you did it yourself. Mm-hmm. You had no insurance, you were dropped, you were let go from your job, and you were, completely and utterly destroyed, if you will. That's just what society did. And of course, we had very limited diagnostic and therapeutic capability back then. That's all changed. We now have people, not only do they talk about it, but they wear pink ribbons and they run races and they raise money for it and they talk about it and they hold up those people high. They call them heroes, they're survivors, and they stand up and they tell their stories. They do it at parties, they do it at media, they do it openly. And 50% of us will get cancer. And so it's not an isolated thing. So I think part of the successes that people don't talk about, and I'm a therapy person, so therapies are cool, and we've done a lot of things. But I think as I look at it more globally, we can actually have this open conversation about it. And I can drill down on some of the therapies, and I may as we talk, but I think understanding our relationship with cancer. Initially, it was this big C word, so we had to declare war on it. We didn't know what the heck it was, to the extent we do today. So, it was all hands on deck. Let's aim and fight this thing, and it was the right thing to do. But to say we're going to completely eradicate cancer, that's tantamount to saying like we're going to completely eradicate death. As we get older, we die, and that is a natural consequence. And cancer is one of those consequences, and it is literally in our DNA. It is dysfunction of DNA that as we age. So, I think we need to, have a conversation, change our relationship, and, maybe refocus it. I tried to think of a term that would fit. And of course, any term you use, someone will take umbrage with it. But, I'm thinking of cancer before its time. And, it will vary with each person. And, I'll state outright that, a 5-year-old should not get cancer, period. A classic example of a mother in her 30s getting breast cancer. It just does not fit, does not compute. It's wrong, needs to be eradicated, needs to be fought. Okay, fine. Someone in their 90s, okay, and you're going to get two people, and one person's going to say, my time's ready, I'm, another person will say, no, I'm not ready yet. And so I'm not saying, I hope this isn't interpreted as a death squad for the elderly and all of that, gobbledygook, if you will. I think it's cancer before its time. And I think we need to address it in the context of what each person wants, where they are in their life, and it's healthcare, and deliver the healthcare that suits them at the time. Now, having said that, do we still have lots of fighting to do? Do we still have a war? Do we have things that are out there that are bad and we need to do a deeper dive on, if you will, and fight? Absolutely. And, I could go on and make a list, but, it is still taking our lives. It's taking the lives of people, and it's taking the lives of people before their time. So in that sense, I think we need to, reframe our war, keep components of it and understand other components of it, and put a bit of a reality check on it. And again, I don't want this to be interpreted. I'm a cancer researcher and I want to battle this. And I definitely think we should. I just think we need to look at it as where it is in the context of someone's own life and lifestyle, life cycle, if you will.
I think you touched on something that in some ways might illustrate this a little bit. I'm thinking of pediatric cancer. There was a time that was a death sentence.
Right.
But I heard you say, and I want to make sure because I think it's a very powerful statement. A child dying any longer doesn't make sense. It's incongruous in a way. And that's a mind shift that's so powerful that in itself would probably justify fighting a war. To be able to say something like, you are likely to get cancer, but you'll do it more on your schedule than the diseases.
Right. Exactly.
Right.
Oh, I like the way you said it, and it fits in cancer before its time, but more on your schedule than the diseases. And I really like that. That actually frames it eloquently.
What made that possible? That's such a profound shift. What is it in research that made that possible?
Well, that's a great question. And I think there's going to be many answers, and I could go on. So feel free to cut me off when I go on too much. But, again, one of them is able to have this discussion that, I mean, you and I are having it here, but, we've all had it. We've all had it 100 times, and we can have that discussion. So that's a really important part of it, number one. Number two is we have a couple. We have many tools that we didn't have, in the early 70s. Vastly increased fund of knowledge, vastly increased number of tools to change it and to diagnose it and to understand it. So I think we can now fine tune it. Instead of, I don't know, just making this up, and instead of the car getting 2 years old and say, oh, no good, must get new car. It's like, well, car's 2 years old and this car got in a major car crash, need new car. This car, needs the engine tuning up, and you look at it and you structure it. Maybe that wasn't a good analogy, but I think going back to what I said, we have more knowledge. We understand the diseases better. We understand them at the kind of the human level disease process. I have lump on breast type of thing. And then we understand it at the molecular process. Biopsy that lump on breast, and it's BRCA2 positive, which means you get a certain therapy, which means we need to look at your family tree, which, and you and your children, and so we have that ability. And then it also means, using that as an example, we have specific molecularly targeted therapy that we can give for that. So, I think it's opened up the possibility to have these finer point conversations.
Would it be too much to say that there's been a very fundamental change in that we talk about cancer as a treatable disease as opposed to a sentence of death? The reason I'm thinking about that is because I just remember the statistics of when I was growing up in the Deep South. You're right, nobody talked about cancer very openly because in most cases you knew what it meant. And that was sad. In my neighborhood, which was a more blue collar neighborhood, there was a child who did come down with cancer, and it was a question of how long. It wasn't a question of what do you do, it's how long. So it seems to me that is a fundamental shift where you see cancer as a disease and not as in effect, a declaration that your time is almost over. And then the second part you mentioned really strikes me, that when you are able to start talking seriously to a human being about, there's a lot in your background genetically that suggests to us that there are markers that may pose a challenge to you. So we need to mitigate that. That's a conversation that I don't know we could have had 30 years ago. Am I right?
Yeah, so there's two parts of it. Let me get to the genetic component in a second. So remind me if I don't, but I think your first part is, it relates to survivorship. And the short answer is absolutely, night and day difference. And as you were you were talking, I'm thinking of this analogy, okay? Diabetes.
Perfect.
There is a picture of this child literally dying in their mother's arms. And you don't need to be a doctor. You see the frail, you can see the bones, you can see the muscles. And, insulin was invented, it brought to bear, tested on this child. I think it was probably the first person who got it. And there's a picture of that child, within a year, I think it's a couple months later, out on the playground, playing, looking like a normal kid. So same disease, diabetes, and along comes a treatment and completely changes that. So same with cancer as a broader sense. Now, cancer is more. I mean, diabetes is not a single disease, but cancer is not a single disease. But as you said, it changed it from basically a death sentence to social ostracization. To now we have survivors, and not only are they survivors, but they're proud survivors. They're held up by society. They're used as examples. They went through something. And even you can subcategorize as survivors, if you will, those who no longer have cancer and those who are living with it. And of course, you can break it down, those who they survived, but it destroyed them, and those who survive and it made them stronger. But the point being is it is a disease and it's now recognized as such. And the other important thing is it's not just cancer. People now recognize that there's a difference between breast cancer and lung cancer and prostate. Not everyone does, but I think most people do.
Let me take you back to the genetic piece, because when I went back and looked at 1953 newspaper clippings and so forth, when Watson, Crick, Wilkins, Gosling, and Franklin confirmed the double helix, and we suddenly began to understand that if we could grasp the molecular nature of some of the chemistry going on, we could actually start to talk seriously about what was going on in cancer. And that led to some of the most profound breakthroughs. Are there some of those changes out there? I don't know if they're necessarily comparable in scope and impact, but are there some things going on right now that you sense have the potential to change fundamentally the way we think about cancer?
Yeah, I believe there's many of them, and actually many is the operative word. And if you think about DNA, okay, in essence, it was the molecular basis of it. Was discovered in the 50s, and to huge insight as it would relate to cancer, and it has, and relates to family history. It relates to many of the cancers we get. And ultimately, the cancers we get are due to defects in the DNAs in our cells. But it isn't just what you're born with. It's the life you live, what you're exposed to. And it's that combination of events, and it's a combination of what you're exposed to and what you yourself expose yourself to. So it's really a part and parcel of who you are as an individual. So you're born with a certain set of DNA, and then and lo and behold, you're exposed to radiation beyond your control, or you're not. Or you decide to smoke, or you don't, or you
do something with asbestos, or
exactly. And so there's all these factors, and they all contribute. Okay, so look at a number of factors. Okay, smoking, drinking, what you're born with, how you decide to exercise, if you're randomly exposed to some chemical or radiation. I could go on and on. And so that's just the factors, kind of, global factors. But then inside there are these changes at the molecular level. So I think what, getting back to your question is, what's the latest ramification? What's that thing that is right in front of us that A, we need to understand better, and B, will lead us to greater insight, and that is understanding all of this material together and integrating it. It's like, how many times have you heard someone say, oh, this person's good, this person's bad? Well, if you pick any individual person, I mean, I've been bad at times and I've been hopefully good many, many more times, but certainly not a perfect person. I think understanding the massive amount of information we have, and then getting useful decisions, getting the information we have, integrating that, and then getting understanding of it on the other side.
And that integration strikes me as comes at a level that you don't see in a lab at that point. That's really some heavy duty thinking about what the nature of the disease is in this broader context of factors that can actually cause the disease. So that's still in the offing, but I get the impression that you think we're close enough to begin thinking about a strategic framework for cancer. Am I right?
Well, yes. And the fact of the matter is we've been using that concept. I mean, what's the human genome? What, 2.6 billion bases or something like that? I mean, we have a hard enough time remembering our 7-digit telephone number. Okay. I think that's why they were designed that way. That's kind of the limit of our, good memory, if you will. So there's only one way we can understand things like that, and that's to extend our memory and computing power with computers. And of course, I'm talking about computers and bioinformatics and integrating that. And of course, they're tools. Okay, just like you and I are talking now. We're using some tool called Zoom in electronics, but you and I are intellectually driving that. And well, just like I'm stating the obvious, just like with computers and bioinformatics, they will be driven by and should be driven by human intelligence, but we need those tools to help us understand these large things.
And I think I hear you saying that those tools, as powerful and as important as they are not going to be as valuable unless we have some integrated framework for thinking through what the data will tell us. So we're still at a point where the complexity of cancer is as much the problem as anything else. Yeah. Which leads me in a strange sort of way to ask a somewhat different question. One of the things that cancer research displayed fairly early on was that the disease had absolutely no respect for academic disciplines. It could care less whether you were a biologist or a chemist or whatever. And that was a bit of a challenge, it strikes me, because in many cases, academic disciplines, especially in universities, are very powerful, not only in how they organize things bureaucratically, but how you view the world. It seems as me the kind of people who go into research administration like you do have to have an interdisciplinary view of the world. But there's not much that I know of still, or maybe it's changed, that instills in you that interdisciplinarity. So what is it that it takes for someone to be a good cancer research administrator, in addition to obviously the knowledge, it's up-to-date knowledge? But that interdisciplinary seems to me to be a factor. But what other attributes of someone who presumes to oversee a research enterprise involving cancer, what other attributes do they need to have?
Well, I think you're talking about leadership as it relates to cancer. But before we go into that, you use the term, cancer scientific administrator. And it's interesting because administration carries this connotation that, you go in and, you're counting beans on a spreadsheet type of thing, or you're making sure someone's following the rules. And in fact, what you and I are doing right now, so that's not it. Okay.
Great.
What we're doing okay, is you could be saying, well, what you and I are doing right now is administration, because what we're doing is we're creating a public forum where we can discuss scientifically important issues.
Mhm.
This morning, I just met with a young surgeon who joined us, and what do you want to do? Where do you want to go? How can I help you? Well, on the one hand, it's administration. On the other hand, I got to meet this really cool young person who had great ideas and was super talented, and helped me frame how we can construct our scientific programs and infrastructure to help him be successful. He's interested in breast cancer. So my hope is maybe I can create an infrastructure so that he can create a more effective, less invasive surgical technique 10 years from now. Well, was I an administrator, or did I help the scientific process? Well, in my assessment, I'm helping the scientific process. And I know that's not how you meant it, and it wasn't chiding.
But your point's well taken.
But it's something I had personally gone through and said, oh, you went into administration. Well, yeah, I did. But what I really did is I went into creating a scientific environment where people who are smarter than me can come in and do really cool things and change it. Anyways, so getting to leadership, what are the qualities that are necessary for leadership, and in particular interdisciplinary leadership for cancer? And I think that the qualities required today of leadership are identical in many respects to the qualities required of a leader throughout all of history, with some exceptions. I mean, there's some notorious leaders, follow me or I cut your head off, and okay, fine. But with many leaders, who they are, I mean, I'll list some of the qualities, but you remove any one of them, and someone who has a passion for what they're doing, a commitment to doing it, an honesty, people want to follow them. The analogy of I'll follow that person into battle, and I may die, but I'll die happily, if you will, because I'm doing the right thing. So those are all qualities of leaders from the days of yore, and there's still qualities right now that people are attracted to. And this is me bragging. I think I'm proud to say I've had many people come and say, Ray, I want to come and work with you, because of the vision you create. And also people want to come, and this is not unique to now, but people want to come and join something good, something different, something exciting. And if you're saying we're going to do this, and if you're part of it, it's good, you're excited. And you see it in biotech industries, and you see it here. So those are all qualities, natural qualities of leader, no matter what you're in. Cancer in particular, to our credit, what we've done correct in cancer, and you're right, it's I think we, and I would say my predecessors, recognized very quickly that it's not just one thing. It's not going to be solved by a single cancer biologist. It's this integrated field. And one of the areas where I like to highlight, most people don't think about it, but most people think about the disciplines, like this scientific discipline and that scientific discipline. But one of the things that we've done really well in medicine is, and cancer has led the way. And if you look at medicine, back in the days of yore, it was the doctor and the nurse and the patient in that order. Okay. And it was top down, and it was highly rigid. And there are still imperfections in the system, but to cancer's credit, it's a real team approach. And you will find most physicians, I mean, you will always find exceptions, but you will find most cancer physicians that will look at this team and look at them as equals. And, for example, we round in the hospital, and there'll be a nurse, and they'll be talking about, a nursing related view of the patient, which is critically important, and how they're integrating with the family, or not integrating with the family, and there'll be a pharmacist there. The drugs we use now are so complex. I'll say, oh, let's give them drug A. And I'll go, no, you don't want to do that because they're on drug B. And I'm like, oh, okay, cool. But, and so it'll be this discussion. And it's this group. And cancer did that. In just the very nature of cancer centers, the vast majority of cancer centers are what's called matrix cancer centers, which means they have members from all disciplines, and their goal is to basically integrate these people across disciplines, which can have their own challenges, but I look at it as a fun challenge. I actually enjoy doing that. So,
But I think you touched on something. I don't know that I was particularly aware that cancer has been one of the ones that has moved away from a strict hierarchical model. And in fact, because of the dependence on care providers who are direct frontline people, they have to be seen as just as integral to the work of research as anybody else, because they're the ones who are going to understand the patient's reaction.
Right.
Do you think that was by design, or was that because we were fortunate enough in the early days to have some individuals with a breadth of intellect? Or is it the nature of the disease, strangely enough?
I think the short answer to that great question is I don't know.
I don't either.
I'd have to think about that. I think that's a great question. I could see it both ways. To me, it's a natural consequence. And was it driven by a few people? Well, yeah. I mean, everything's driven by a few people, but maybe it's driven by a few people, and it's a natural consequence. So let me repeat. Great question. I don't know.
But I think what really makes it, to me, in many ways, is much an interesting question, Mark, is that it suggests that the people we need to look for as leaders need to bring two things: a breadth of intellect and interest and inquiry. Someone once said to me that the best quality you could have as somebody who attempts to administer a research enterprise is in inexhaustible curiosity. And I've always thought about that. And in a way, I think your point about the dilemma of saying whether it was the early leaders or whether it was the disease, I don't know that I could draw a line between that. I really don't know when I think about the people who led the early days.
Right. Well, I think you've hit upon one aspect of leadership in particular for cancer that I think is key. And that is that curiosity and the ability to go where the new things are, if you will. Not that you should ignore the old. I mean, I've seen a lot of, it's new, it's better. Well, new is not always better, but there's new things. So, for example, you've heard me mention bioinformatics. The understand.
Yes.
I'm not a bioinformatics person. I won't be a bioinformatics person, but I know enough to know that it's important. And I'm actually trying to learn a little bit of bioinformatics, not so I'm going to be pushing the field, so to speak, but so I can actually have a conversation. And those who are pushing the field, I can help them push it by saying, by integrating my experience with what they're doing. And that's the fun part. But I think in cancer in particular, you need to do that. Another example is just this idea of inclusion. I've been saying for years that we understand the pharmacokinetics of drugs as defined in a Caucasian population. Well, guess what? You look at different populations, they have different sets of cytochrome P450 enzymes, just to give an example. And they handle drugs differently, and we don't, and so we're now it's now to the fore that we need to, and we should be including all individuals in our studies and in our outreach and engagement. And that's another form of something new. and thinking differently. And, you need to do that. I mean, you should be doing that. We should have been doing that. But, that's kind of another somewhat related thing. But, here's two aspects. One, bioinformatics computers,
Exactly.
and one very, for lack of a better way to put it, very sociological, but both new concepts that you need to adapt to and understand as best you can as a leader, or you will fail your field and your institution.
One of the reasons we were so attracted to you as a guest for Innovators was because you were very clear in your interest at forging stronger ties with public health. Is that part of your effort to build the strategic framework, integrated framework, is that what really propelled you to really focus on the importance of creating close ties with public health? Is that where that came from?
I'm not. Can you reframe the
Sure.
question a little bit? Yeah.
Early on, we sort of got a sense that for you, cancer research was incomplete without a strong tie to public health.
Got it. Yes. Okay.
But you came to that on your own, as far as we can tell. And it seems to be extremely important to you now, even more so perhaps then.
Yeah.
What drove that?
Yeah. Well, actually, what drove it is actually, it sounds rather odd, but I think it was my logical entry into it. So, the joke is I love drugs. I love therapeutics. I love pharmacology. I just do. Just like someone loves an orchestra. I love thinking about how drugs work and how we can make them better. And so, when I did fellowship, I just fell in love with research, did drug research, and so I like to say I got into prevention by a consideration of cancer biology 101 and a consideration of pharmacology 101. And, cancer biology, very simplistically, but also truthful, is complexity increases with time. Okay. And the number of abnormalities increase with time. Okay. Pharmacology is one drug basically works against one target. Okay. One drug never hits one target. It always hits multiple targets. We call that off-target or toxicity effects. But in general, most drugs basically therapeutically modulate one target. So if you treat cancer in very advanced stages, there's multiple molecular abnormalities. Even if you give multiple therapies, they're only going to hit a small subset of them. However, if you can go back down the spectrum of cancer and apply therapy in the context of fewer molecular abnormalities, you'll basically increase your therapeutic efficacy or therapeutic window.
Got it.
That's what brought me into cancer chemo-prevention, as it was called back then, or using therapy to treat people who are at risk for cancer. And I still do that. I love doing that. And that's basically applying molecular pharmacology to people who are at risk. But, that opened up a set of windows, spectrums, problems where I was interacting with people in the prevention field. You can't divorce prevention from public health. And so interacted with epidemiologists and, prior universities, I've led their prevention programs. So my interest in and thinking about that scientifically led me to focus in this area, which then, basically opened the window for me to look at those people in the different disciplines in that area, look at public health. Now, having said that, is public health important from any way you cut the pie? Absolutely. I mean, just look at COVID rolling out, okay? And I heard a new term, okay, politically neutral. So all of my comments are meant to be politically neutral, okay? And if anyone interprets them any other way, they're just wrong. But look at the arguments and the public health issues that are just going on with COVID. And again, I'm not going to even give an inkling to the politics, but any aspect of cancer, okay, advanced cancer, well, does it affect public health? Yes, it's a huge financial cost. Cancer treatment and therapy is very, very expensive, as is all of healthcare, but hugely impactful. That has major public health considerations. Okay, fine. What about early screening, early detection? Well, that's prevention. Well, there's people who believe in prevention and early screening and people who don't, and there's huge public health consequences to that. So, yeah.
It was a natural thing.
It's a natural thing. I went there by maybe an unnatural way.
It's a little bit,
but it's critically important.
One last question, because I could sit here and talk with you the rest of the day, but let me quickly.
I love the conversation.
Let's just assume for the moment that you have the wherewithal to fund 3 projects very generously on a sustainable basis.
Yeah.
But you're going to have to make the choice. Of those 3, which areas of cancer research would you put your money on right now?
Yeah. And, so you're asking me, it's my opinion, and, people hearing this could, I'm sure they'll say right or wrong, but that's okay. I think I would bin them into 2 areas. Well, one is we need useful knowledge, and then we also need useful tools in a way to apply it. And that, in my assessment, falls out into 3 areas. One is bioinformatics and, understanding all of this information and integrating it. And you and I have chatted about it.
Mm-hmm.
So I won't go into the why. I'll just list it, and for all the reasons we talked about. The second area is our drug development and clinical trials process. Highly inefficient. It currently costs $2.6 billion to, develop a drug.
Mm-hmm.
And if you look at the FDA requirements, they're relatively simple. And, we, meaning the industry as well as academia, we can't stop ourselves. It's like, we got to do this next test. It's almost like an addiction. And what I'm getting at is do all these tests to look for efficacy and toxicity, and 30 to 50% of the cost of developing a drug is actually preclinical. And our preclinical models, everyone will say they're terrible. And the first time you go into human, even though you've tested it in mice and rats and dogs and monkeys and whatever, they're not human. And you go into humans and there's a huge failure rate there. So, and there's a huge barrier. I mean, we can synthesize chemicals in the laboratory,
Right.
And there's all these obstacles there that preclude us from taking it into human, from actually synthesizing something. So if I had a magic wand and had some money, I would lower the bar by which investigators who have good ideas can have compounds synthesized
Mm-hmm.
and then given to humans. And then the whole clinical trials infrastructure itself. I've been in meeting after meeting, the regulatory requirements go up and up and up. And we go in these meetings and say, oh, we need to decrease the regulatory requirements. Everyone looks at each other, everyone agrees, and then they go out and they do the opposite. And it's only become more complex. And it's like everyone wants to collect everything, and everyone wants to conduct, here's the issue. Everyone wants to conduct a clinical trial like you do in the laboratory, and you simply cannot control that. I mean, here, there's two human males right here, right on the screen. Well, are you and I identical? No, we're not. You can just look at us and see that we're not identical. So, why put in all these requirements that when you give you a pill and me a pill, we're going to handle it differently? Now, we need to have some bars. I mean, if
Sure.
I have, horrible medical problem, I shouldn't go on a clinical trial. And we shouldn't be collecting all this information. Okay. The fact is that, maybe you have more hair than I could somehow be important. And, one could argue that we need to collect that information, but let's have a bit of a reality check. Okay. Mm-hmm. And if it turns out that pill somehow responds differently in people with different hair amount, we can go back and get that information. I'm using this as a completely silly example.
No, I understand. But your point's well taken.
And it's a huge, so fix that. And then I think the third area is, in fact, prevention. to build in our strategic infrastructure. It's something that industry does not fund, and I'm not criticizing industry at all. It's a long-term goal. It's something that needs to be funded by government. But if you look at a decrease in our cancer rates, it's all early detection and prevention.
It is.
It's all being driven, okay, by early detection of lung cancer. When I say all, I mean probably 90 to 95.
I was going to say at least 90%.
Yeah. But and that is recognizing the damage that tobacco causes, going through the decades of battles, legal, sociological, scientific, and then of course the NSLT, the National NLST, the National Lung Cancer Screening Trial that showed that we could detect it, decrease mortality, and iterations of that are now coming out. And I'll go to clinic, and the fellows will come in and present a patient with stage 1 and stage 2 lung cancer, and it's like, it used to be stage 3 and stage 4, and now it's stage 1, stage 2, and they're now cancer free, and it's amazing. So yeah, and the same thing to some extent, early detection. So if you look at lung, colon, breast, and prostate. And they all have issues.
All prevention.
We can detect them early and intervene. And not to say, prostate's a good example. We really intervened, and we did a lot more surgeries than we needed to. But 10 years afterwards, mortality decreased. And now we're the pendulum is swinging. We're titrating that, but that's where we'll make the biggest impact.
Dr. Bergan, I wish we had a couple of more weeks to talk. Unfortunately, I think you have probably rounds. I want to thank you very, very much for your time today. It's been a delightful conversation.
Thank you for listening to Innovators, a production of Harris Search Associates. We'll have more insightful conversations with global thought leaders to follow.